What's up, guys? Chris with CNC for Newbies here. I wanted to go live. I've had a lot of questions on setting up uh, my wasteboard and setting up wasteboards in general. But I set up my wasteboards a little bit differently than most. I talked about it last night, and all of a sudden I got an influx of questions, comments, concerns as to how I'm actually setting stuff up. So I'm going to give you a little bit of insight on what my thinking is, how I do it, and why I do it. Okay. First things first, whenever I have a 4x8 machine and I'm not able to get 5x10 material to do a full wasteboard over it, I get regular MDF, 3/4 inch MDF from Lowe's, Home Depot, any of the big box stores, and I sister them together. And what I mean by that is I get a piece of hardwood. Hold on one second. Let me flip the camera. Back camera. Okay. So I'll get a piece of hardwood and I'll actually scribe a line. I'll cut it with the circular saw. So I take a piece off of the top layer. This is 2 layers of MDF. And that will create a lap joint whenever I put the back piece on. But on this bottom piece, so I have mounting holes here and I have wood here. I will actually take a piece of wood and span this bracket, this split in the MDF. I'll span it, and I'll actually use not screws, bolts with fender washers and nylock nuts. And I'll use I forget what they call them, Forstner. I'll use a Forstner bit to actually drill and make the hole bigger for the fender washer to compress this layer of MDF and the sistered board underneath, and then the filler piece. Okay. Then I'll actually lap the second piece of MDF coming from here to here. I'll lap it over this piece of MDF. And then I'll screw down a countersink with an Amana countersink bit. You can use a regular countersink, but man, these things right here, they're awesome. It's nothing spectacular. It is a little expensive, but I use it all the time. So it's a countersink with a bearing and a standoff. So it just goes in. Every one of my holes are standard depth based off of the top of the surface. So I'll actually countersink all my holes here. And I'll sister this top piece of MDF onto the bottom with a lap joint. Okay. Then I'll continue my screwing here and then on the back side. Okay. Then I'll surface this whole system. Okay. Once I surface the whole system, let's see here. I use an insert cutter, 1.5 inch to surface my wasteboards. And I'll make sure that my spindle is absolutely trimmed, and I'll surface my wasteboard. On top of that, with this wasteboard, I'll be adding T-track. So I don't actually piece boards together on top of my MDF. I will cut into my top layer of MDF a pocket for my T-track once everything is surfaced. But to lay out my T-track and make sure that I have everything set up the way that I want, I actually use the computer program to do that. And what I'll do is I know that from the edge, I need 3 inches. And the reason why I need 3 inches is I use these intersection pieces. So if I do that and that'll be 3 inches from the edge. Okay. And this allows me to get cross pieces every 36 inches. I have a cross. So I'll actually have multiple small pieces that will go across and tie the T-track into a grid. So each one of my side pieces needs to be 3 inches. Then I simply mark center lines and measure. In my case, it reads 45 and a little over 3/4, but I started at the 2-inch mark. So if you're at the 2-inch mark, you've got to subtract 2 inches from your 45. 45 and 7/8. So it'll actually be 43 and 7/8. When you divide all that out, you'll divide it by one more than the pieces you have, because if I put 3 pieces of T-track in between those two, that'll give me 1, 2, 3, 4 separations. So you split that into 4. You just put the 43 and 7/8, divide by 4, and that'll give you your center line spacing for each one of these pieces of T-track in between these two. All right. Once you do that, you can pretty much scribe everything. Then I'll come up here, I'll scribe it again, and I'll come up here and I'll scribe it again to make sure that my T-track stays in line. I'll use my 10-foot level. I'll lay it across the table. I'll strike my straight line from there, from the 0Y to the 101Y, and I'll strike a straight line on all 5 pieces of T-track. Then I'll come through. I'll go 36 inches from the Y0 point up, and that will put my intersections, because my intersection pieces are 3 inches. So that'll give me my center point to line up my intersections. And then I'll lay my intersection line out across, and that'll give me my grid pattern. And the intersections just come 4 pieces. They bolt together like that. And that makes for a very simple T-track setup. And I'll do that. I'll have 36 inches across brace or cross T-track, then 36 inches and across T-track, and then the remainder up here. Then in between each one of these T-tracks, I will have 2 rows or 3 rows of screw downs. I call them nutserts. There's an actual name for them. It's the same stuff that you get in the X-Carve kits to do the spoil boards. Offhand, I forget the name of them. I just call them nutserts. But basically what I'll do is I'll mark out, I'll drill the hole, I'll countersink the top of it just barely, and then I'll put 2 or 3 rows in between the T-tracks that will allow me to then make my grid pattern for fixtures. And I use the machine to cut all of the points for the screw bolt downs and the T-tracks, because then I'm assured that as long as my axes are square and my trimming is done correctly, that the machine itself is making parallel attachments to the spoil board in reference to the axes. Okay, that's very important that everything's in line. Then right now I have a lot of stuff just as prototyping, but I'll actually mount my board back on the front here. I have a separation board that I'll actually create a flush bump stop about 4 inches into the Y, and that will allow me to quickly bolt it up. I'll use the machine to cut across, and when I cut across, that will make that bump stop parallel to the x-axis. So now I'll have a T-track, I'll have a nutsert, and I'll have a bump stop that I can work off of, being able to quickly align and clamp in pretty much any which way I want. So I could theoretically use T-tracks to quickly locate my fixtures in left to right, front to back, and then use the nutserts to finish the alignment, the rough alignment, and then use a dial indicator to quickly finish the final alignment for setups. So that's kind of how I do it. Like I said, the big thing that gets people is the math involved. I don't know why. The easiest way I found is however many pieces you're putting out, add 1 for your division. So you take your length and then you divide by how many spaces you're actually going to have, not by the number of T-tracks. You actually do it by the spaces. So I take my number of T-tracks and add 1. So I'll divide this by 4, and that'll give me my center lines. And then once again, I just go over to the computer. I set a step distance. You Gerbil guys can do the same thing, just in your step distance. I'll put 3 inches. So right now I'm locating off of my X0 and my X max, which is 50 inches. So I have X0 and X max. So I go to X0, I put a step of 3 inches, I do a positive move. Okay. Then I push the machine all the way over to the soft limit at 50 inches. 50 inches is the soft limit. It is not the max travel, but I'll push it all the way over to 50 inches. And notice I have a pointer in there. I just have a simple V-bit. It's a 60-degree V-bit to give me my rough alignment. At the 50-inch mark, I'll go a -3 movement, and that puts me right where I need to be. Now I can measure out my 3 other T-tracks. I'll have the numbers, so I can actually just run a quick program up and down. I'll be able to see if my screws are in the way, and then I can actually go in between each setup and put a 2-inch grid for my nutserts for fixturing and stuff like that. And that's quick, easy, dirty way to get great aligned T-tracks and make sure that everything else goes exactly to plan. So guys, I'll let you go. I just wanted to share that with you. Have a good day.